Alright, hey guys, this is take 2 of me making this video because I screwed the last one up so much. So let's go ahead and try this all again. We've been working with all those properties, right? We've got our big organizer. Hopefully you've got that sitting right next to you while you're watching this video because we are going to use all of those properties from your organizer and start applying them. So looking at number 1, it says that UVWX is a rectangle. So this figure over here is a rectangle. Alright, cool. We know that a rectangle is a quadrilateral with 4 right angles and that it shares all the properties of parallelograms, right? So let's just go ahead and get started. It says that XW is what we're looking for. Alright, well XW is over here and we were given that UV is 12 inches. Well, alright, it's got all the properties of a parallelogram, which means the opposite sides are congruent. So XW is 12 inches. And our justification for that is if rectangle, because that's what we started with, right? We started with a rectangle. So if we have a rectangle, then opposite sides are congruent. Okay, well then we're looking for UW. Alright, so let's look at our picture. UW is one of the diagonals. Well, the other given up here is that XV is 13. XV is also a diagonal. And we know that in a rectangle, the diagonals are congruent. So UW is also 13 inches. And again, our justification, it always starts with if rectangle for this one, because that was what we were given. We were given a rectangle. So if rectangle, then diagonals are congruent. Okay. Now we're looking for XM. Okay, let's look at our picture. XM is this portion of our diagonal. Okay, well we have to think about the other properties of a rectangle. So take a look at your organizer real quick, see if there's anything else that might help us here in terms of diagonals. Well, with a rectangle, it shares all the properties of a parallelogram. And in parallelograms, the diagonals bisect each other, which means that XM has to be congruent to MV because it's getting cut in half, it's being bisected. Well, the whole thing XV is 13, so the way that we can get XM is to cut that 13 in half. So 13 divided by 2, and we get 6.5, which means XM is 6.5 inches. And our justification for that then is if rectangle, then diagonals bisect each other. Alright, and let's see, measure of angle UXW. So UXW, that's this angle over here. Well, since this is a rectangle, all 4 of those angles are right angles, which means they are 90 degrees. Okay, so our justification for that is if rectangle, then right angles, then 4 right angles. Right? That's actually the definition of rectangle that we started with the other day. We said, hey, if we've got this quadrilateral with 4 right angles, then it's a rectangle. So there we go. All right. Moving right along. Again, if you don't have your graphic organizer out, pause the video and go grab it because we're going to need it. We're looking at a rhombus now. Okay, well, a rhombus is a 4-sided figure with 4 congruent sides that shares all the properties of a parallelogram and has a couple of its own. Okay, so we need to find VT, which is over here, and we need to justify our answer, of course. Okay, well, since it's a rhombus, I know that all 4 sides are congruent. So I'm going to go ahead and put tick marks around to help me out a little bit, because now when I look at it, I can see that 9x minus 11 can equal 4x plus 7, because those are both sides of my rhombus. Okay, and then I can solve for x. So 5x minus 11 equals 7. 5x equals 18. And we get x equals 3.6. Make sure you got your calculators. It's okay to get decimals sometimes. That happens, right? So don't freak out. It's okay. And we are looking for VT. Well, again, since they're all the same, means I can plug this x equals 3.6 in pretty much wherever I want. So I'm going to pick SR. So 9x minus 11. 9 times 3.6 minus 11. Grab your calculators, and we get that VT, or well, actually SR, because that's the one we're looking at specifically. We get that SR is 21.4. But since it's a rhombus, all of them are 21.4. So that's VT that we were looking for. And the reason we were able to set up this equation and able to get that measure was because we had a rhombus. So if rhombus, then 4 congruent sides. Okay, you have to think about, okay, why did I set up the equation I set up? And that's the justification you're going to use. Okay? All right, another one with a rhombus. So we need to find the measure of angle WSR. So WSR, I'm going to go ahead and put a question mark there because that's what we're looking for. And we need to justify our answer. Now, I'm going to let you guys know we're going to actually have 2 justifications for this one. So bear with me. I didn't leave you a spot for 2 justifications, but you are going to have 2. Okay? So, taking a look here, I've got to think about a rhombus and all the properties of a rhombus. Well, I was given TWS, that angle, is 2y plus 10. And I was given WST, that angle right there, is y plus 2. So take a look at your graphic organizer, look at the properties of a rhombus. We've got to think what's going to help us here. Well, the first thing that jumps out at me is that WST and WSR are actually congruent to each other. And the reason that I know that is because diagonals bisect the angles, which means if I could figure out what WST is, what that angle is, then I could figure out the one I want. So I got to figure out how to get that, which means I need y. So I'm kind of guessing that I'm going to need to look at the other angle. Well, TWS is made by the 2 diagonals, and in a rhombus, diagonals are perpendicular, which means that that angle right there, let me use a different color, that angle right there is going to be a right angle. So 2y plus 10 is equal to 90 degrees. 2y gives me 80, and then I get y equals 40. Okay, and the reason I was able to set that up again is because I know that when I have diagonals in a rhombus, they are perpendicular to each other, so they're 90 degrees, those angles. Okay, well now we said that WST and WSR are congruent to each other. So the measure of angle WST, well that's y plus 2, so that's 42 degrees. That means then that WSR is also 42 degrees. Okay, so again, we've got 2 justifications for this one. So the first one, we were able to say that that's 90 degrees because we had a rhombus. So if rhombus, then diagonals are perpendicular. Diagonals, perpendicular. Okay. And then the second justification, the reason we were able to say that these 2 are congruent is because we had a rhombus. So if rhombus, then the diagonals bisect the angles. And so we were able to conclude that those 2 pink ones were congruent to each other. So once we found one, the other one was the same. Okay, you're going to have to be able to read these figures. All right, you're going to have to be able to look at that and go, oh, that's right. In a rhombus, diagonals are perpendicular. Pull all that information and be able to solve it. Cool? All right, so a couple more that we got to look at. So, looking at number 4 right there, we got a lot going on, right? We've got a rhombus, okay? And we are given that the measure of angle GCD, so this angle, I'm going to use pink, is b plus 3. Okay, and then we were also given that CDF, angle CDF, is 6b, so I'm going to use purple for that one. 6b minus 40 degrees. Okay, so I'm going to label my picture nicely so I can kind of see what's going on. And I have to remind myself that I was given a rhombus. Okay. So the first thing that this question actually asks me for, though, is the measure of CD. So I have to take a step back away from my angles for a second. And I have to look at those sides, apparently, because that's the first thing it's asking, right, is for CD. So CD is right here. But this is a rhombus, right? And in a rhombus, all four sides are the same. So I'm going to go ahead and put my tick marks, which means this is very similar to, what was it, number 2, okay, on the other page. So I'm actually going to have you guys finish finding, I want you to find A, and I want you to figure out the measure of CD, okay? And I am going to move on actually then. So now we want to look at those angles then. Okay, I'm looking for the measure of angle GCH. So GCH, I'm looking for this angle right here. I'm just going to put a dot there, okay, to show which one I'm looking at. Well, when I look at these angles, this pink one and the purple one, they're consecutive, right? And we know that in a parallelogram, consecutive angles are supplementary. Well, a rhombus is a parallelogram. So I'm going to go ahead and add those together and set it equal to 180. So b plus 3 plus 6b minus 40 has to equal 180 degrees. And so I get 7b minus 37 equals 180. All right, and if we keep solving, we end up getting down to b equals 31. Okay. With that then, I'm going to leave you alone because I want you to look back at question 3 to help you finish figuring that one out. So question 4, I'm going to check it tomorrow in class and make sure that you have got it finished. You should have an answer for CD and a justification, and then an answer for the measure of angle GHC along with a justification. Okay? Again, look back at numbers 2 and 3 if you need some help finishing that up, or stop in the MRC, come see me, whatever you need to do. Okay? But we will talk about it. I want you guys to try it. Alright, then we got one more thing that we are going to look at right now. So we are given a rectangle. Okay? So I need you guys to highlight that for me and think about the properties of a rectangle, right? It's got all the properties of a parallelogram, plus we've got that the diagonals are congruent, and we've got some right angles going on, right? So let's think about what we can do here. First thing I'm going to do is I'm going to actually go ahead and make this a right angle, because that means if I can find one of those, that I'll be able to get the other, because the right angle is 90 degrees. And I'm also going to think about the fact that this line is parallel to this one, because it's a rhombus, or a rectangle, excuse me. So what that means then is if I use this as my transversal here, I can get the measure of angle 1 pretty quickly. Right? Because I've got these parallel lines, and then the 54 is right here, and I'm looking at angle 1. Angle 1 is also 54 degrees. Okay? Now, the justification for that is a little strange. It starts out with if rectangle, then opposite sides parallel, right? But we can also follow that up with, well, how do we know it's actually 54? Cool, I got some parallel lines. but then I'm going to have to follow it up with if parallel lines, then alternate interior angles are congruent, right? Hopefully you're having some flashbacks to chapters 3 and 4, because that's where we used a lot of that. But if you need help seeing that, just extend those lines a little. There's one parallel line, there's another parallel line, and again we drew in that transversal already. So these two angles are alternate interior angles, which means that since those lines are parallel, those two angles are congruent. Okay? Taking a look then at some other stuff. What else do we know? Well, we know that in a rectangle, the diagonals are congruent to each other, and we also know that they bisect each other, which means that all four pieces of the diagonals in this rectangle, they're all congruent to each other, because the diagonals are congruent, and then we cut them both in half. So it makes sense that all four of those pieces would be congruent to each other, right? So think back to chapter 4, and if we look at that triangle up on the top, this is essentially what we've got. Here's angle 1 and here's angle 2, and we've got that these two angles are marked congruent. So if we think back to chapter 4, we know that those sides are congruent, which means the angles across are congruent, which means angle 2 is also 54 degrees. Okay. The main thing that we are pulling for that justification is if rectangle, then diagonals congruent, and then we also know that if it's a rectangle, diagonals bisect each other. Okay, that's why we were able to then get that each of these pieces were congruent. Okay, moving along, angle 3. Well, angle 3 is right here. We said that since this is a rectangle, this was 90 degrees. So if we do 90 minus the 54 that we already have, we get that the measure of angle 3 is 36 degrees. Okay, we know that because we have a rectangle, so if rectangle, then 4 right angles. Okay, so let's see, we got that this was 54 degrees, now this is 36 degrees. Okay, which means by using that same if angles then sides property, I get that this angle down here is 36 degrees. Okay, and I'm looking at angles 4 and 5 now. So I'm going to draw that top triangle again over here and show you guys something real quick. We had those two sides, and we said angle 1 and 2, those are both 54 degrees. Okay, and we are looking for the measure of angle 4, so I'm going to put a question mark. Well, hopefully you guys look at that and automatically know what to do. We've got a triangle, and the sum of the interior has to be 180. So we know that we can add those two angles together and subtract from 180. Sorry, that took me a second to get that out. So 54 plus 54 plus the measure of angle 4 has to equal 180 degrees. So if you do some math there, you should get that the measure of angle 4 is 72 degrees. Okay, and we actually know that that justification is going to be the one that I let you not write an if then for. This is because of the triangle sum theorem. Okay, we know that the sum of the interior has to be 180 degrees. That one has nothing to do with the fact that it's a rectangle, but we couldn't have gotten angles 1 and 2 without knowing that it was a rectangle. Okay, does that kind of make sense? One more that we got to do, measure of angle 5. Well, 4 and 5 are next to each other in this picture, which means that they are supplementary. So if I do 180 minus 72, then I get that the measure of angle 5 is 108 degrees. Okay, and the reason that we know that is because 4 and 5 are actually a linear pair, but we're actually just going to write angle 4 and angle 5 are supplementary. Okay, we're not going to jump all the way back to some stuff from chapter 1. So you need to know that idea, but not a theorem behind it. Please make sure that you finish number 4, and I will check it tomorrow. I will answer any questions you have, and we'll keep working with these properties, okay? I'll see you guys later. Bye!